Okay, so I think most people are still trying to stream in a little bit, but it's now a little past the starting time, so we'll go ahead and begin. Welcome to the panel on, let's see, implementing virtual reality at scale in the field, challenges of spaces and places. I will be moderating the panel along with Kyle Johnsen over there. And we have here a collection of a diverse set of expertise in essentially taking virtual reality and implementing it at scale outside of a controlled laboratory space where you are bound to run into a lot of unintended and unexpected issues that have to do with the space of the place and also the logistical and administrative problems of the place as well. And so we're going to quickly kind of go through each panelist's area of expertise and their most recent experience in bringing up the virtual reality projects to scale outside of the laboratory. And then we'll also spend, I think, most of the panel's time addressing the questions that you might have in terms of perhaps your interest in taking virtual reality technology outside of the laboratory or any specific questions that you might have for the panel. And for that, we'll be using this application called Slido. It's very simple to use. If you have a smartphone or a laptop in front of you, you go to slido.com and enter this number. So it's S018. It's not S018. It's S018. 16. Evidently, I need more coffee. So it's S016, and once you enter that number, you should be able to type in your question. You're also able to see other people's questions. They're completely anonymous, but you can enter your name if you want, and you're able to upvote or downvote different questions so that all of the questions will start floating up to the top, depending on the votes that the questions receive. And so we'll try to address as many questions as we can in much more of a kind of a live stream manner than the more traditional panel structure where each panelist talks about his or her research at length. And so we'll see how that goes. Let's see. Let's go ahead and begin by introducing each panelist's area of expertise. And I guess we'll go in the order of how you're seated. And so, Kyle, do you want to kick it off?
Sure. So my name is Kyle Johnsen. I'm from the University of Georgia. What I'm doing here, obviously co-organizing with Grace, is we recognize that the projects that we're working on have been really, really challenging for us in that we're trying to take research, but run this research at much larger scales, both in terms of numbers of systems and an amount of time these systems are deployed with a much larger diversity of people that are expected to work with them. And this has been sort of stunning to us, how much harder it is. And it's almost a completely different area of research. And I've been doing work outside the lab for a long time, but just with one system deployed, trying to maintain that one system where I was going to be there and it wasn't going to be there for very long. And so scaling up virtual reality research has been very challenging. Two projects in particular that I'm probably going to focus on here. One at a museum, which I assume a lot of people who here has done any sort of museum type experiment. There's several people in the room here. So one, running at a museum that's been running for 2 years now at the museum where we're not there every day. And then another one that is at 12 after-school programs that's been running for the past year. Deployed VR systems out at after-school programs that the after-school programs expected to run. And so those two projects, and I'm happy to talk about them more, I'm sure I will, but I'm going to pass it off to Erica.
Thanks, Carl. Just bring the website up, thanks. I'm Erica Southgate. I'm from the University of Newcastle in Australia, as we say. I'm a humanist in technology. I'm very interested in bringing immersive technology into schools, into real classrooms. and in particular into schools which are in low socioeconomic school communities, because I think this is our lost talent for the sector, and if we can engage these kids in learning through this technology and about the technology, they can thrive in the future, and so can we as a nation, economically and globally. So I also have a role where often government hires me to write translational texts. So I'm the mediator between the technologists and the teachers, where I need to explain to them what the technology is and how they might use, what the evidence is on the technology for learning and how they might use that. And that's across a number of technologies, immersive technologies and also artificial intelligence. This is one of my main projects, VR School, and as one of the teachers who's worked on the project over 2 years remarked, it's a very arduous project. And we'd like to talk about, some of the things that happen in the field, which don't really happen in labs.
I'm Christoph Borst. I'm from the University of Louisiana at Lafayette. I've also been doing virtual reality in schools, and so we've been delivering virtual reality field trips primarily to high schools, also in some other venues like a public library. So that's the short description. A little more interesting is that these are networked virtual field trips. So we have groups of students being guided by a teacher who may be located in another place, in another city or another state. And what we have been applying this to is field trips of a virtual solar plant, so the students can learn how the electricity is generated and about the different devices in the solar plant, so they can get some appreciation of alternative energy production. I guess this is my first time deploying something outside of the lab, and it's a lot of obstacles and a lot of extra work to overcome. But yeah, I really wanted to push this because I really wanted to go in the field and see how it really works.
Hi everyone, my name is Babu. I'm from Clemson University in South Carolina, USA. And I've been doing VR research for about 16 years. And with regard to doing field studies, there are 3 key experiences that I have. One is built virtual reality systems to educate medical practitioners in a variety of patient interviewing protocols, especially with regard to patient safety, hand hygiene. My undergraduate degree is in microbiology, so I've always been interested in somehow integrating medicine and virtual reality for some time. And as an educator, I'm also interested in how virtual reality can be used in K-12 education, especially to promote children and minorities to take an interest in science, technology, engineering, and math, or what we call STEM. And I worked on a National Science Foundation funded project, which I can show a video of, where we implemented technologies to educate middle school children in computational thinking concepts and programming concepts via a fun and engaging activity using virtual reality of different ways, modalities of immersion. And more recently, I've been funded on a new grant in which I'm required to, or I intend to use virtual reality towards educating undergraduate geology students in virtual reality in field experiences, in simulated field experiences. Because geology majors cannot go to the Grand Canyon and other interesting locations to perform geological experiments, soil collections, rock examinations, things like that. But they can do that in virtual reality, both using 360 videos as well as with simulated content. So I've been funded on a new grant. I'm just starting this work right now for the next 3 years, where we'll be developing simulations to provide virtual field experiences to undergraduate geology majors.
Okay, thank you.
Hello, I'm Dr. Maki Sugimoto, and I'm a 23 years surgeon And I'm also a co-founder of the Hollow Eyes company. It is VR and AR and MR development company for medical images. The main term is the development of medical image reconstruction using the VR. And I also have some project about medical education, mainly for surgical navigation and simulation or the surgical educational systems.
Okay, thank you very much for sharing all of your areas of expertise. And I think this is a really critical conversation to have, because all of these scholars are, I guess, they're implementing their studies in different areas, in different spaces. And this is a type of knowledge that rarely gets systematically delivered to the rest of the field. And so usually what people tend to do is they tend to kind of make the same mistakes over and over again. And so hopefully this sort of panel discussion will allow us to share our accrued knowledge so that you avoid making these mistakes, or you avoid going through the hurdles that we had to go through by way of sharing our knowledge with the rest of the audiences. And so it looks like there are several questions. And if you just joined us, you are able to ask your questions from the audience as an anonymous person, an anonymous asker of questions. And you go to Slido or slido.com and you join us at S016, and you're able to upvote these questions that you like, or you're able to ask your own questions as well. So why don't we go to the top of the question list, and it's what unintended consequences have you encountered in the field? And I'm going to just kind of open it to the panelists.
So with regards to using virtual reality technology to provide awareness of computational thinking concepts and computer science concepts in the K through 12 classroom, oftentimes when we want to measure the effectiveness of a tool, we create pre-tests and post-tests to study how effective a tool was with regard to the educational benefits to students. And so when you're designing cognitive questionnaires, presence questionnaires to students, especially middle school students who are 6th and 7th graders, you can't just take questionnaires that are standard questionnaires in the field and directly apply them. So we have had to, oftentimes we face the challenge of, well, we want to measure this phenomena, if you will, or this construct like presence or co-presence, but we quickly realize that we have to actually modify the questions in order to be able to utilize them effectively in the field. And then there is also the question of whether students are able to understand, interpret the questionnaires that you create in order to measure a construct. And so I quickly realized that I need to work with educators who are in that K through 12 domain, who understand children and who are able to provide feedback regarding how to create questionnaires. Perhaps it needs to be concise, it needs to be sort of short rather than lengthy ones, because there may be a question of perhaps focus or attention. So we have had to construct new inventories when we have conducted research in the field, especially in K through 12 education.
So in the research I do, it's mixed method research. And so we use a range of things. We've got motivation instruments. We've got pre and post test knowledge tests to look at knowledge mastery, content mastery. We're really interested in metacognition, for instance, about how students manage their own learning with new technologies, given the novelty effect, but also around kind of distraction and staying on task. And I have to say, we've got a whole lot of things going on there, but one of the most interesting things was that technically the system that we set up, which was networked Oculus Rifts, just kept, the server kept dropping out. And one of the things we really wanted to do to capture metacognition was do screen captures of the behaviour in VR. So both verbal, like you capture it verbally, but also the non-verbal behaviour, because there's a really nice literature on metacognitive, self-directed learning through non-verbal behaviour. So we had this grand plan of doing screen captures on the networked machines, and every, I don't know, a few minutes, they would unexpectedly, the screen capture would just stop. And so I was running around the room just trying to restart it all the time, or trying to get the kids to restart the screen capture. And so what you get is often very patchy kind of data, although, you know, this is the nature of working with technical systems which aren't robust, and in schools where the network isn't unlocked and you have to create alternative kind of access to the internet because it's, say, the network's locked down by the Department of Education. So in terms of research, we have to be very robust in field work because it's not going to be this systematic controlled data collection of the lab, I have to say. And we need to be able to write about that, both in terms of what it can show us, but also the limitations.
Well, I was handed the microphone, so I must say something. Right? No, I can echo what was said before. We used some standard questionnaires, but what we mainly did was abbreviate them. You know, following up on what you said. And we also had a lot of problems with networks. We would go to the school, and there would be an announcement in the morning over the intercom saying the network is down for the day. And we're doing network research. What do we do? So we always had to have some kind of fallbacks. If the network didn't work at all in the school, we would bring our own equipment and set up our own LAN. If the network to the university wouldn't work, we would run between two schools. So we always had this kind of fallback. The other kind of, well, the question asked about consequences, I say the other kind of problem we encountered is really different kinds of classrooms. So some schools are able to give us a nice space, and as coming out of the lab, we like these nice controlled spaces, and we think that's how research should be done. Another school only gave us sort of a very noisy workshop or project type space where students were working on a lot of projects, talking to each other, talking to the teacher, and we thought, oh no, our results are going to show that VR doesn't work because there are so many distractions. Yeah, but we felt that's a real environment. If we're going out into the field, we have to evaluate in the real environment. So we included that as a variable in our setup. You look like you want.
Yeah. So one of the things that's been so surprising about working on a large-scale system is how hard it is to be sort of clever and exciting with your technology, because that's the stuff that breaks. And you just have to simplify things to the point where it might not work. It's no longer as exciting as you thought it was going to be. You thought you were going to be able to develop a system that everyone's going to be able to use, and it's going to be so intuitive, but ultimately you have to build something that's going to last. It's going to stay in running for 2 years. And so that's been the most unexpected consequence for me, that I thought we were going to be able to really innovate on the 3D UI side, but in reality, we have to build something that, somebody can use for just 2 minutes and get something out of and leave. And then the next person comes up and the next person comes up. And oh, by the way, they're all different heights and different skill levels. And just you have to develop really simple interfaces that are really easy to understand. And it's very, very hard. It's so much harder than, you know, when you have an hour with this person in your lab and you can explain so much and go through a training. You just can't do that.
In a medical application, in a medical setting, especially for in a hospital or a medical university, it's a little bit hard to keep their motivation. But I think the goal is not only their excitement or development, but for a patient or for the general people. So we usually use the evaluation system for not only for a trainer but also trainee. Both trainer and trainee should have motivation to develop more efficient VR system in a medical setting. So we are usually using not only the computer graphic data, but also patient individual data in a clinical setting like a CAT scan or MRI. So in the actual operative field, we gathered the trainee and the trainees during the actual operation. That's the real environment. That's the point to bridge the virtual and the real world, right?
Okay, thank you. I just wanted to jump to this really amusing question. How do you deal with the case of children? As if it is a... And we know from experience, Kyle and I work with the YMCA after school of Metropolitan Atlanta, and they are a very special case indeed. So let's quickly discuss this curious case of children before we move to the next question. And I think, Erica, do you want to?
I mean, I love kids because I was trained as a teacher, but the kids in Australian schools are not docile creatures. They're active. They talk back. They want to know stuff. If things don't work, they make a joke about it at your expense. And you've got to be really kind of have a lot of humour and a lot of goodwill. But the thing I've noticed about kids in the schools that I work with is that they don't, maybe a third of them haven't got a smartphone because they can't afford it. Most of them haven't got enough data on their smartphones anyway to do educational learning or homework with. When they have to borrow equipment from the school, because it's a bring your own device policy, but not many of them have devices that are really appropriate to use. When they borrow equipment from school, what they do is that they collaborate and they share and they problem solve together. So the case of children actually is one of watching immense kind of potential that we need to tap into really as adults in terms of thinking about how they problem solve, how they collaborate, how they come up with solutions to technical problems that adults can't actually. So I think the case of children is one of great potential and learning, and they never seek to amaze me in terms of the way that I'm trying to think of a really good example of that. In terms of a way that getting stuff to work technically or getting stuff to work in a project that adults struggle with. And so the teachers in our classes are guides on the side. They're not the sage on the stage telling the kids what to do. They're facilitating the potential. And I think in terms of taking technology into the field, that's what you have to be.
And I think we can't just group children as a large chunk. They're not a singular category, right? Younger children are very different from, let's say, middle-aged, middle school children. They're very different from, the toddlers. Does anyone have anything to say about different categories of children and how they require different approaches?
I think the most startling thing for me has been the cognitive differences of very young children. So you might have a classroom of 7-year-olds or whatever that you're working with, but some are at a 9-year-old level and some are at a 3-year-old level, and we have to survey them just dramatically different because some can't read. And so you're doing pictorial scales and things like that. And now you have to deal with that in your analysis, that you've got some that have done pictorial scales, but you're deploying the same system and the interface can't have text in it. And so it's very difficult to design for that audience when the diversity, when you're dealing with 20-year-olds, they can all read, right? You can explain things to them. They can ask you questions. Kids don't ask as many questions. They just think that it's going to work, and they think they know how it's going to work. And they do experiment, though. They'll try stuff.
They do.
So.
I wonder, Grace, if we can play that video.
Yes.
Sorry.
In this video, we introduce programming moves, design and evaluation of applying embodied interaction in virtual environments to enhance computational thinking in middle school students. What is VENVI? VENVI stands for Virtual Environments Interaction. Vinvi is a visual programming tool that marries dance and computational thinking in pursuit of enhancing students' enthusiasm, excitement, and interest in computer science. Due to a lack of representation of minorities, especially African Americans, Hispanics, and females, in computer science and STEM fields in the United States, Vinvi was created with the intent to engage 5th and 6th grade girls with computational thinking. This research will test the hypothesis that girls creating interactive movement for their visual characters and using their bodies to think through the actuation of the characters should bootstrap their intuitive knowledge in order to learn computational concepts, utilize computational practices, and develop computational perspectives. Vinvi was inspired by Alice, Looking Glass, and Scratch. They are all programming environments that use animations to tell stories and play interactive games. Looking Glass uses linear interpolation animation, which causes the virtual characters' dance movements to look static and robotic. In an earlier study, although middle school students enjoyed seeing their characters perform, they desired more fluid movements than were available on this initial platform. Vinvi improves upon Looking Glass's user experience by utilizing motion capture animation and the Unity game engine for virtual character dance movements. We use trained choreographers to motion capture hip-hop dance moves. Using a motion capture suit, we recorded pelvis, forearms, head, and lower leg movements. The data collected from the human motion captures were used to construct a 3D virtual skeleton, which we translated and rendered to the virtual characters dancing in Vinvi. To perform our study for Vinvi, the curriculum was broken into 3 phases. Phase 1 was Learn to Dance. In this phase, students learned a dance sequence, the cha-cha slide, from an instructor as an active learning process. These dance movements will be used later for programming sequences in Vinvi. Phase 2 was Code to Dance. In this phase, students programmed dance moves they learned through embodiment into the Vinvi user interface for their virtual characters to perform. The user interface in Vinvi is divided into 3 major areas: the drag and drop area, the move selection area. Vinvi features 6 key computer science components: sequences, loops, do together, variables, conditionals, and functions. The Show Code button allows Vinvi users to see what their block sequences look like in pseudocode. The last major user interface area is the Virtual Environments window, where users can see their code being performed by a virtual character in a virtual environment. Phase 3 was Get Inside the Dance. In this phase, we created an immersive embodied experience within Vinvi to augment the visual programming model with immersive virtual reality. To facilitate the highly immersive embodied experience, we made use of the Oculus Rift head-mounted display and Microsoft Kinect V2 motion sensor. Using these technologies, the user can see their hands and feet from a first-person point of view as they interact with a dancing virtual character in a virtual environment. The intent for this interaction is for the user to dance with the pre-programmed virtual character in the virtual environment. Benefits of this immersive embodied interaction metaphor include telepresence, social presence, enjoy.
So this was a tool that we used to teach computational thinking in 6th and 7th grade students in middle school. And basically, in order to answer the question that was posed by the audience, what I want to tell you is that basically when we, using this tool, we performed several interventions in partnering middle schools. We partnered with multiple middle schools in the South Carolina upstate area. And as part of our activities, we quickly realized that whenever we wanted to, so we would have to teach a concept such as sequences, variables, functions, etc., and then have students pick a song that they want to programmatically choreograph a dance performance for a virtual human for. In the process, learn the programming concept and apply it. So when we initially just said, this is what sequences is, this is what variables is, that was not sufficient. And then the middle school instructor who was watching us said, can you provide some real examples, perhaps some motion examples with which you can teach sequences, functions, variables, etc. So we went back to the drawing board, and then we designed some activities. We said, okay, for sequences, imagine that you have to clap your hands first, and then jump, and then do some other actions. So one after the other. And so we had all the students come up with a sequence of actions that they could perform, and we got all the students together. We stood around in a circle, and we performed these kinds of motions. And once we did that, then the students actually understood what that computational concept was, or what that concept was basically. And then they could then implement that concept programmatically using our tool. And it also helped enable students to sort of come together, focus on the material, and through an activity, we were able to bring them all together. Otherwise, if we were giving a lecture on sequences, for example, we would quickly lose them within 2 to 3 minutes. So the problem of focus sort of kicked in. But once we were able to come up with our technique of teaching a specific concept and then allowing students to programmatically create it in the virtual world, choreographing a dance performance for a virtual human using that concept, then we, once we could find out what that best process was that worked for the students, then it worked like a charm. And we were able to conduct over a period of 3 years many interventions in partnering middle schools in that regard. So initially there was a very steep learning curve with regard to what kind of activities do you do and how do you convey these abstract concepts in a concrete manner to the students.
Okay, let's jump to the next question, which I think is very relevant to the theme of spaces and places and our challenges that we face. The question is, what technology changes are coming that will remove barriers that you've faced, and what challenges won't be solved by upcoming new technologies? And Maki, do you want to start?
And, I'm a surgeon, and we usually use the VR for patient-informed consent and training and simulation. And mixed reality is used for actual surgical procedure during the actual surgery, because we should know much about the actual environment in the real time. And we want to watch the virtual reality, not only the virtual reality environment, but the actual field. So the HoloLens and Magic Leap is very useful for mixed reality devices in Japan. But the Magic Leap is not allowed legally in Japan because the electric situation and so on. But we already developed some application for HoloLens and Magic Leap. It's very useful because we can match the location and the position of patient CAT scan data and actual patient anatomy at the same location during surgery. So the trainer and trainee want us to know much about the correct anatomy during the actual surgery, right? So virtual reality is the data of the virtual reality is very limited because we need to develop before the user using this VR system or application. But you know, the mixed reality, we can calculate the actual environment real time, and we can integrate these data to the point, I think. And the mixed reality is the challenge for the remove barriers of about now the virtual reality, the limitation of the virtual reality now.
Mm-hmm. And Christoph, do you want to?
Yeah, well, what would have helped me with the barriers I faced is definitely, you know, maybe some lower cost, some nice low cost standalone VR devices, which are coming out now anyway, by the way. But when we started the Rift and the Vive did not even have the wands yet, so. This is already changing. We carried our own equipment to schools because they didn't have it yet. So it will be nice when they can all, for very low cost, have a bunch of these standalone VR displays. It will make it much easier to deploy this sorts of things. The networking was a problem, as we mentioned before. So if we have stable, reliable networks, I think the technology is just there, but it's about the support that we get from people to make sure everything is running smoothly. What challenges won't be solved just by having better devices, trying to figure out how to keep the content engaging over long periods of time and make sure that students are actually learning from it and they don't just sort of habituate and get bored of it and start looking for something that's more fun and entertaining.
There's an interesting challenge that I've realized in trying to deploy 12 simultaneous running VR systems, and this is a challenge that won't be solved by technology. It's that when you have lots of systems deployed, you're very reluctant to make any changes because it's really, really painful to make changes to those systems. And so content is going to be an issue, but when, again, deployed systems, you start acting like a company, right? It's like we're gonna have a phase in 3 months, or maybe at the end of a year when our study's done, we'll actually fix things because we can't fix them all at once because there's only a few of us. So these challenges are always going to be difficult, I think. But maybe some of the the newer systems that maybe you'll be able to deploy to a store and patch things like that, and not try to be managing your applications as 6 separately installed applications, but kind of installing them through a store kind of thing, and people get updates. That might help.
I have to say there's been a lot of talk, much more talk than I've heard before at this conference, around the harvesting of biometric data through headsets. And when you have really low-cost standalone headsets roll out to schools, for instance, and they pick them up, or to libraries or to museums, I think one of the things we need to address, and this community can address right now, is around the ethics of harvesting biometric data and educating people on that and giving them real decision around control of that data. And I think that's a real challenge that will come with the new technology. So while the new technology will be affordable and roll out, at scale, I'm very concerned that the educative process, the ethical educative process, won't roll out at the same time. It's really hard for people to understand, for instance, with the intersection of machine learning and the harvesting of biometric data, what that means for their privacy, because that's often very opaque. And I get very, very concerned when I hear lots of people at this conference talking about that as if it's a fantastic, wonderful thing, which it is from, I suppose, a laboratory research point of view, but it certainly isn't from a public point of view.
So for some of the problems that might not be solved by technology, I think it includes soft skills and personal relationships when you are out in the field. Does anyone want to weigh in on how you accessed these middle schools, how you developed the relationships that allowed you to establish these field experiments?
So I think I'll attempt to comment on this. So when we went out with the intent to use VR technology to educate middle school students in STEM-relevant activities and computational thinking, we first approached the principals of these schools, and they were oftentimes very interested in us coming in and engaging with the local middle schools and using VR technology. But the kinds of questions that they were mostly interested in is what type of systems are we going to bring in? So would we be bringing in head-mounted displays? Would we be bringing in wearable sensors? Because they're mostly interested in sort of parental consent related issues. If we are to use wearable sensors, we need to get parental consent as well as children's assent for the same. That is something that we do anyway as part of our institutional review board requirement, is that any student that participates in our programs has to provide assent, and the parents also have to provide consent because they're minors. And so, but the principals are very interested, are very curious about the types of technology that the children have to wear, and what might be some of the unintended consequences of that, for example. For instance, if flashy images on a head-mounted display could cause eye strain, or worst case scenario, if the child may have a seizure, for example. So those are things that we need to take into account, and we need to think about those kinds of medical impact. And we would always ask the students, and as part of that assent process, we would always make sure to ask to inform the parents that all of this, there are some medical consequences, and if they're willing to allow their child to sort of participate in this VR program. But we would also create non-immersive options. So most of the technology that we used towards middle school intervention were desktop virtual reality simulations. Because what we could do immersively, we could also do on online virtual reality simulations and desktop VR simulations. So primarily, that's what we actually used as part of the interventions. Principals of these middle schools were also interested in how we can meet them where they are with their demands for education for middle school's children. So every state has certain standards and requirements as far as education is concerned in the K through 12 program. So they're curious about how our program could perhaps complement some of the educational goals that they have towards middle school education. So if there was a computer science awareness course, many middle schools in South Carolina have such courses, then they are interested in using our virtual reality intervention as part of that course, where we could perhaps for 6 or 7 weeks do a course and relieve the instructor towards computer science awareness by using our Venvi as the intervention during that period. And in that manner, the schools are very interested in integrating our program as part of their ongoing curriculum and as part of their general education requirements. So we have to also see how can we meet with the general education requirements of that school.
I'm going to jump up there to the top, the types of insights you gain from field experiences. And I wouldn't say it's so much field experience as much as the scaling up your experiments really forces you to choose technologies that work and are robust. And that's maybe not the most exciting thing, but it does yield insights into what actually is a good idea and what's not a good idea. For example, using Connect type interactions for selection is just really, really hard, and I've yet to figure out how to do that effectively. And we've tried a whole bunch of different things that don't work, and have gone to touch screens, and we have touch screens now on our systems so that you can actually select something and it doesn't randomly do that because kids don't seem to get that. And so it forces you to, back away from certain technologies that aren't 100%. So.
Are we talking about the? Yeah. Pick a question. I was thinking on the previous question. Well, what kind of insights? The amount of sort of distraction that students have in VR was surprising to me. They would get in VR and sort of look around and want to click at things. I guess you expect that. And they certainly don't want to listen to a lecture in VR, so we had to make things a little more interesting. And then when we networked them together and they could hear each other and see each other's pointers, they want to talk to each other and you know, also not listen. And yeah, I mean, in the end, by making the interface a little more interesting and this experience a little more interesting, it's still worked out. But it surprised me how much they get distracted in there. Really? Yeah. Well, I don't have kids. I don't work with kids that much. Maybe maybe I. Yeah.
I'll be really brief. I haven't got a lab because I'm in education and they don't give people in education equipment or labs or generally. I've got to tell you, I've got a suitcase that I drag around behind me like the Pied Piper and take stuff to schools and show them. So I do, one of the really interesting things I do is participatory research with teachers. So to teachers and I design the projects from the ground up in terms of what they want to do. So I don't come with a project that I want to implement. I work with the needs of the teachers, the learners and the curriculum. But one of the things that I think is really interesting with new technologies is that we need to incubate them in place. Unless we incubate these technologies in place, in the real places where you want to scale up, you'll never find out what's going on. And I'll give an example of that. Within the first week of the VR school project, the pilot phase of it, we realised that we needed a child protection protocol. Now, of course, if you're a physical education teacher, you understand that there are practices and procedures around helping students put equipment on in physical education. We hadn't even thought about this in VR. And so other kids were helping other kids put equipment on, we were helping kids put equipment on, and the teacher and I turned it to each other and said, we need to formalise a procedure and educate the students on this so that there aren't any child protection issues, and so that children who are touch adverse, for instance, if you have special needs or religious or cultural issues around touch, are treated respectfully. And we would never have known that unless we'd gone out into a classroom and set the equipment up and actually incubated that in place.
Yeah, I guess I would have to agree with Erica. And before you set out into the field with your virtual reality project, I guess it never really struck me how exaggerated your controlled findings are, because the kids are not, or your participants are not dealing with the outside distractions. And so during our pilot studies, we had amazing results because everything was controlled. And then you take it out into the field, and it's just astounding how quickly your massive effects can be diluted. And I think it's just, unless you test it out at a certain scale, out in the field where you don't have this much control, you just don't know how effective your projects tend to be. So let's move on to the next question. This is a very philosophical, why VR? How do we move away from the hype and make learning experiences that use VR affordances at the core of learning? So why are we focused in VR?
For us, there are many limitations in a medical setting, right? Because we cannot kill the patient by the young student, like a resident or something. So we wanted to copy the procedure, surgical procedure or treatment procedure in the actual medical setting to the medical school, but we need the VR. But not only the VR application, there's also have a limitation in the VR setting because the VR data is not the patient, and the patient individual data is different by patient. So we integrate these barriers between the virtual reality and real medical setting to use the patient-specific data and mixed reality, right? So we put the healthy people here, and we put the patient data on them. So we make the students to have some simulation for surgical procedure or medical treatment and so on. So it is very useful to have some reaction from the healthy people, how they feel or how they have the anxiety or something. So that's the point, I think. Yeah.
So I think this panel is actually directly speaking to the why VR question. The why you run field studies, why you scale up, is to force you to start addressing the real questions, to start addressing the real problem. Because once you get to 6 or 7 months into the study, there's a lot of fatigue that's happening, and people aren't excited about it anymore. So the tech starts to go away, and people start going, well, is this thing actually working now? And so that's why you go into the field. That's why you don't just run the lab experiments, because there's so much excitement at the lab experiments that you're not actually studying the real thing.
That's right. I mean, really, teachers, anyone wants to know, is it worth it? Is it worth my investment, the hassle, the financial investment, the fact that I have to adjust my curriculum and my pedagogy, that, I have to, control the kids who are, jumping out of their skin with excitement or running around or, whatever's happening. And so we really do need very robust research. We need research which is mixed methodology. We need research at scale with reasonably big sample sizes so we can make some claims. And we need to be honest. So if our research doesn't show the finding we would like, we need to be honest and talk about that and theorise why. And I think we need interdisciplinary research. Usually this stuff comes with a kind of interdisciplinary kind of context around it, and that's really important in terms of bringing stuff out there into the real world. I mean, there's no way schools are going to invest at this stuff at scale unless they can see a real impact on learning. So, it's about making the case, I suppose. Is it worthwhile?
Well, in my case, to answer the why VR question, we're dealing with an application where I think it really helps to have a first-person view, because there are these mechanical and electrical devices, and you want people to have an appreciation for how those work or move, and you have a solar field, and you want the students to get an appreciation of the size of these reflectors, and I think VR helps a lot with that. Also long-term why VR. The basic idea here is you cannot bring the students to all these sites. So, VR lets you do it virtually. We all know that already. But I'll tell you a story that is not sort of about the educational part, but we did a sort of a long-range network, feasibility test from Lafayette, Louisiana, all the way to Adelaide, Australia. So this is like 10,000 miles of fiber optic cable. And I was on sabbatical, and I had not seen my students for a while, and I was in Australia, and I put my headset on, and my student was standing before me. He was represented using a Kinect capture. Right, it was the mesh being streamed and reconstructed on the other end. I was just really excited to see that, and when I saw that, I was like, this is really how we're going to be communicating in the future. To see someone standing there before you. Yeah, I don't know if my student wanted to see me that much, but I was very happy to see my student.
So I think that leads in really nicely to this question about how do you build your interdisciplinary teams, and what elements of your projects tend to be interdisciplinary?
So when we designed our educational virtual reality simulations, I think this also relates to the previous question, where if we were only computer scientists designing these training simulations or educational VR simulations, I think we would be very short-sighted in terms of our design. So oftentimes, we need to work with cognitive scientists, especially when it comes to training and educational simulations, because they know exactly what type of scenario works effectively when it comes to training users in a specific task. So I think through experience, we have realized that the research is best accomplished through the sum of the diversity of talents that we are able to bring forth. So when I work on these educational VR projects, it's with cognitive scientists, it's with educators who are actually working in the field, domain experts that can provide input on the scenarios that we need to create so that we can provide this repeatable, meaningful experience in virtual reality for the trainees, whether it be in the medical domain, in the mechanical education domain, when it comes to computational thinking or STEM research and STEM education and awareness. So we need to work with real educators as well.
Could you show my video? Could you show my video? And I will show you my research work in a medical setting. And the title is IEEE 19, IEEE 19 video, short video.
I got it. It's right
here. All right, so let's see. I think this is a really interesting one. So a recent New York Times article, and I read this article, it claims rich are banning screens from the class, while poor children get screens instead of humans. How do you think this will affect VR in education? Meaning, then are we exposing only the poor to VR and not the rich?
Are you pointing to me because? I mean, if we do a really good job and make VR really effective, this is good for the poor, right? That's kind of a funny answer, but there must be a happy medium between the two. I mean, I'm all for banning screens to an extent, but if we make effective educational technology, there's definitely a place for it. I'm not familiar with the article, by the way. I would be interested that if we could do like just show of hands, who leans more towards just banning screens and who leans more towards just putting kids in front of screens.
Yeah, in the audiences, who is for banning screens? Which makes sense.
No, I'm a little, maybe not banning them entirely, but at some point a person still needs to like crack a book and be able to think deeply and think about abstract things, to solve interesting problems. So I don't think VR is gonna fix everything.
And I think this is sort of this question is it's the exact opposite, or it's complementary to, why VR? Let's focus on something, right? We're just complaining about the technology or thinking the technology is the solution is same thing, right? It's about the what is the technology being used for? Is ultimately whether or not it should that's the conversation we should be having is what is it showing? What's the screen showing? What are they doing? And what's the alternative that they could be doing? And so, we're not going to ban screens, and it's not, I mean, the rich don't exactly make great decisions when it comes to education either, paying for college and things like that. So it's yeah, I think that we need to do a really good job with the types of things that we give and not just think that the screen's going to be better or that the screen's going to be worse. It's going to be about the content that we put in there. And yeah, they still need to manipulate things and learn, hand-eye coordination and things like that. And video games can be good for that. So yeah, I like the question, and I think we do need to focus a little bit more on what alternative things kids could be doing in the classroom, but I don't think that technology is the problem or the solution, it's the content.
Yeah, and I guess what's really striking about our experience in the field is that we tend to go into very high poverty concentrated areas, and I think our initial concern was that the penetration rate of technology would be very low, but it was to the contrary. I was astounded by the number of children who were already owners of smartphones at a very young age. a lot of them already had wearable technologies. And so I think even when we go into areas that might be very high in poverty, I think there's a pretty high penetration rate of recent technologies. And we have had very little entry barriers in terms of getting children to be engaged with virtual reality interventions, which was, it was something that I didn't expect before I went out and observed this in the field. Let's see. Let's jump to how do you decide, and this is a really difficult question, how do you decide what data to toss out or clean from large field samples?
Okay, so I've got this problem right now with the kind of data I've collected with the VR school project, which is quite a lot of data on quite a lot of kids, and also with the control group. So it's we're kind of sifting through this now. I think the interesting thing with data, I mean, it has to have validity. Like, you have to have validity with it. So you have to ask yourself, you know, how have I captured it? Is it, you know, useful in terms of revealing certain phenomena or certain trends or certain behaviours, or, you know, what am I going to do with it? But one of the really interesting things that we've found when we've used such a broad range of mixed methods, for instance, is that the person in the field often has to be intimately involved in the cleaning and the interpretation of the data. So it's not something you're going to fob off to, you know, a research assistant somewhere and say, just clean that up, off you go, because they haven't got the context. Does anyone watch Star Trek? Context is king. It's absolute king in this. So, for instance, we've got some screen capture. We want to code it whether the kids are on task or off task in their interaction in Minecraft when they're building a body organ in Minecraft. Are they on task or off task? So I've got a research assistant coding it for that. We've done some iterator reliability stuff. We've done, you know, we've tried to be pretty robust. I come and I step in because I want to just check that it's been coded properly. And I notice, so she plays a bit of the video. There's a kid who's strapped some wings on in Minecraft and's flying around, just flying. And she's coded as off-task behaviour. And I said, hang on, just play that a little bit more, that video a little bit more. And what the child was doing was actually flying around the environment to get a view at scale of the body organ they'd built. So they're actually on task because they were checking the prototype of their design. And so I think one of the things around data and being really careful with data in this context is that if you're in the field, you have to be intimately involved with the analytic process, which is something in a lab which isn't necessarily the case. It's very time consuming.
Well, I'll just add, when you talk about tossing out data, I think you just have to be careful to be objective also, right? Because there's a lot of suspicious things that can happen there. In our case, we had to throw out cases, you know, if the bell rang and the students all changed, you know, had to switch classes, or we had some background questions about what was their prior knowledge on this topic. So we threw out cases where they had already been exposed to something similar, but we didn't worry about this problem too much.
When we do these interventions in schools, I always tell my graduate students that try to measure every nugget of data that you might be able to gather in the field. Because we realized through some of our early interventions when we worked with middle schools that we were not gathering, for example, some data pertaining to when the intervention was actually made with regard to the self-reports or some of the things that the children said as they were actually creating the dance choreographies programmatically. Then we realized after our initial studies that we could potentially, if we gathered that information, we would get some insights into their think aloud protocols about how they're solving problems. So we also do audio recording now of their vocalizations, for instance, when they are working on programming problems that they're solving through our tool. And also any artifact that they create through our simulations. There is also a character customization interface in our Venvi tool, for example. In our initial interventions, we did not record the final models that they created. Later, we found out that there was actually a very strong influence or effect between the characters, the types of models that the character the appearance of the characters that the children created, and the types of dance choreographies that they programmed for those characters. So we were able to find that later on through another study. So it's important to gather the artifacts that they create as well. And then with regard to motion, we actually found out one of our surprising results was that when we had these programming challenges in the middle school classroom, where finally groups of students would program choreographies using our tool, and basically in the end, towards the end of that intervention, they would show off what they had created. And in the process, we had at first a large screen interface where the children could show off their dance choreographies. And some of the children who are not shy, for example, would dance in front of their creations. But some others would not. However, we also came up with a opportunity where they could, there was a VR setup towards the end of one end of the classroom, where potentially students could don a head-mounted display and then view their performance from inside, as you saw in the video. And we noticed that the children who were actually shy to dance in front of the large screen display in front of other students were more willing to dance when they were inside the head-mounted display. There was something about the fact that now that they're in this head-mounted display and they can't see the other students in the classroom, they felt perhaps less shy to dance with the characters for whom they have created the choreography. So we also video recorded what children did in that dance contest towards the end of the intervention. And if we did not do that, we would not have documentation of how, for instance, one metaphor of viewing their dance choreographies, their programmatic choreographies, made a difference, and whether they participated with what they created or not.
Okay, so I think we're running out of time. So this is the last question that we're going to try to answer as a panel. Let's end with, what was the biggest mistake you've learned from in running a field experiment?
It's like an interview question, right? What's your greatest weakness? And you have to say, my greatest weakness is I care too much and I work too hard. Well, no, I would say, I mean, we made, I don't actually know. We made a lot of, small mistakes. We had versions of, we had prototypes where something did not work right, where it looked like it just would not be effective for education. But I don't see these so much as mistakes as, these are findings in a way we can learn from them. We can improve the system.
Oh, well, we won't judge. What is the one catastrophical mistake that you made out in the field?
Well, I mean, we knew going in early that we really wanted the system to be safe, so we didn't want to use navigation techniques that would make people sick and all of this. So we, we had people always sitting facing one direction, usually using teleporting. And some kids just really wanted to run around. I think it was a mistake to let people push keys and run around in VR in that kind of environment.
Kyle?
I would say one of my biggest mistakes is trying to run studies that are, the site's an hour and a half away and you have to go out for tech support all the time and not budgeting properly for that. That's a pretty gargantuan mistake. So think about that.
Yeah, I mean, time, it just takes much longer. And also the fact that we hadn't factored in a really robust pilot study, and we should have. So when you go into the field, do a small pilot, pick up, maybe 50% of the things that are happening that are going to, stuff you up, and then, then do the real study.
Yeah, I think one of our biggest mistake, another one, is trying to roll it out to 12 sites all at once. Instead of rolling out in small increments, we decided to go big.
And we usually use the 360-degree photo or video in the circumstance for virtual reality medical simulation. But occasionally we cannot fit the size of the circumstance and the virtual reality. And in the early time, we are using Wi-Fi reception. Yeah, we need the Wi-Fi reception to have medical simulation. So in local hospital, there's no Wi-Fi reception, especially in the operative room. So there's no reception. We cannot do anything. That's the biggest mistake in our setting.
We also created educational simulations for workforce development. And I remember that when we created these educational simulations for engineering trainees at a partnering technical school, we hadn't tested the simulation entirely, so that when we actually went there and we ran the simulation, it just wouldn't run. And for our trainees, this is part of their workforce development aspect. So they are, for them, time costs money, essentially. So you do not want to waste your trainees' time. And so the biggest lesson learned there is to test and retest your tool under different platforms before you go out and do a field study.
Okay, thank you, panelists. Let's all give them a round of applause. Thank you. And these questions are all saved in Slack, I believe.
In Slido.
In Slido, and so we should be
are.
able to address these questions later as a panel. And we're hoping to continue this discussion and maybe develop it into a paper so that we're able to disseminate this knowledge to the rest of the industry, the field, who are interested in scaling up their virtual reality projects.
Thanks for all the great questions. It's really awesome.
Yeah, thank you for the questions.
Exciting.
Before you all leave, I'm supposed to make this announcement that the reception tonight is from 6 to 8 p.m. at the Riga Royal Hotel. It's in room Corin, which is on the 3rd floor. At 5:45, if you go down to the first floor using the escalator or elevator B, you should see the student volunteers in red shirts, and they will guide you to the reception area at the Riga Hotel. All right, I hope to see you there. Thank you.
Thank you.